Hello and welcome. And this video we're going to look at critical path analysis. And for us to do that, we've got a question here that is from the Institute of Purchasing Management. Right. So using the information in Table 1, assume that the project team will work a standard working week, which is 5 days in 1 week, and that all tasks will start as soon as possible. So we've got the projects that are given there, and we want to draw a critical path. But before we do that, I just want to remind you of how we're going to draw this diagram. So this is a node, activity node, right? On this activity node, you will find useful information about the project. And the useful information that you'll find is obviously the activity. So A is activity, and you'll find the earliest start time. You will also find the earliest finish. You will also find the latest start. You will find the duration and as well as the latest finish. So when we draw our nodes, we're going to make sure that all that information is included. But before we even put in all that information, the key things is to link all the activities together on a network diagram. And that's what we're just going to start by with focusing on. Right. So I'm just going to draw the first node there, which is activity A for activity A. So that's the node. And then I write A. And then we are told that A requires 5 days. So I can put my duration right away here, 5. Right. And then this information about the predecessors, it tells us about which project follows A. Right? Before we do A, which project do we need to do first? That's a predecessor. So A follows no other project. So A is basically the start. Now, we also have B here, which follows A. So we're going to have B. So we're just going to put B in front there. And this B follows A. So B follows A. And B will take how many? 15 days. So 1, 5. And then after that, we're going to have C, which follows B. So because I can see there's D also follows B, E follows B. So there are many projects following B. So I'll put C here. Alright. I do this. This C, it follows B. And then the duration there, C has a duration of 15 days. Yes, C has a duration of 25 days actually. 25. And then we go to project D, which follows B and has a duration of 15 days. So this is C. We are now doing D. It has a duration of 15 days. This is D. It follows B as well. So we can put an arrow which shows that it's following B. And then another project which follows B is E. And E follows B and has a duration of 30 days. this is E. Duration is 30 days. 30 days actually. Right. It follows B. Right. So C, D, and E have they do not follow each other. They all follow B. Right. Now the next one is F, which follows C and D. So C and D. So F should be somewhere here. And F takes 10 days to do. 10 days, and it follows from C and D, like that. Now, the next activity is G, which follows E and F. G should be somewhere here. So this is my G. It follows E and F. And G, how long does it take? G takes 10 days. So my duration there is 10. Now, we've got H, which follows G and has 5 days. So H will be in front of G. And takes 5 days. It follows from there. And then finally, we've got I, which follows H and takes 5 days. It takes 5 days. It follows H. Just like that. Okay, so basically that's our network diagram with the duration inputted. Now for us to be able to do the next task, which is the calculation of the critical path. The critical path is the path which has the longest duration if followed. In other words, that path will not have any slack. Any activity which is not on the critical path will essentially have some slack on it. So, for us to identify the critical path, we need to identify the various routes that we can get to the end. So if we start from A, we can follow this route and then go this way, and then this one, here, here, and finally there. So if we are to add that A plus B, and then to C, then to F, then to G, then to H, and then to I. And then we can add that for A it takes 5 days, plus 15, plus 25, plus 10, plus 10 for G, plus 5 for H, plus 5 for I. Right? So that's one way of getting to the end. And then another way of getting to the end, we can go from A, then to B, then to D, then to F, then to G, and then there we are to H, and finally to the end. Right. So that's A plus B plus D plus F plus G plus H plus I, which then means we are saying 5 plus 15 plus 15, yeah, 15 plus 15 there, plus 10 plus 10 plus 5 plus 5. And then finally we can use this root here. A, then B, then E, then G, then H, and finally I. So that's from A plus B plus E plus G plus H plus I, which is equal to 5 plus 15 plus 20 plus 10 plus 5 plus 5. And then if we are to add to see the totals of this, 5 plus 15, that's 20, 45, 55, 65, 75. So this gives us 75, 5, 20, 30, 45, 55, 65. So this is 65, and then 20, 40, 50, 60. So this is 60. So effectively, this is the critical part. So our critical part is the A, B, C, F, G, H, and finally I. So that's the activity on the critical part. Now, if you want to find the slack on those activities that are not on the critical part, you simply find the difference between the critical part and the activity which is not on the critical part. So for instance, to find the slack of D, the slack or the float, so we can identify D and E as activities that are not on the critical part from there. D and E are not on the critical part. So slack at D is equal to 25 minus the duration at on the critical part minus the duration for that activity which is not on the critical part, minus 15, which is 10 days. And then slack at E, right. So there are two activities on the critical part for one activity for E. There's C and F. So we're going to add C and F, which is 25 plus 10, and then we subtract E, which is 30. And then we get 5 days slack for activity E. So that's how you calculate the slack there. And now, the next task that we have to do is to calculate our earliest start and earliest finish time. And for us to do that, we use what we call the forward pass. Now, for activity A, since it's the first, we assume that it's starting on day 0. So that's the earliest start time is now, which is 0, plus the duration of the activity, which is 5 days, which gives us the earliest finish as 5. Now we go on to the next. This one will only start after project A, so it will start on day 5 plus duration of 15 to give us 20. This one will only start after B, which is 20 on day 20, plus 15, plus 25, I mean, which gives us 45. So we continue with our forward pass. So this will start on day 45 plus 10, which gives us 55. We'll start on day 55 plus 10, which gives us 65. We'll start on day, I'm just double checking there, 20 plus 25, 45, 45 plus 10, 55, 55 plus 10, that's 65. 65 plus 5, that's 70. 70 plus 5, that's 75. Alright, so that's the forward pass. Forward pass will help us to calculate our earliest finish time. So earliest finish time is equal to earliest start plus duration. Now, for us to calculate backwards, for us to calculate the latest finish time, we're gonna use the backward pass. Let me just change the marker there. Backward pass. And for the backward pass, we're gonna say latest finish time minus duration is equal to latest start time. And as you have noticed, if you've noticed, we've started with all the activities on the critical part. So you need to start with the activities with the critical part before you go to everything else. Always start with the critical part. If you don't start with the critical part, you effectively get your critical part wrong. Right. So latest finish time, which is 75 for the critical part, minus duration, which is 5, will give us 70 here. And then here, 70 minus 5 will give us 65. 65 minus 10 will give us 55. 55 minus 10 will give us 45. 45 minus 25 will give us 20. And then 20 minus 15 will give us 5. And then 5 minus 5 will give us 0. Alright, so that's that. Now for activities not on the critical part, so if we take activity D, so this will be, the earliest start will be 20, and then the earliest finish, 20 plus 15, will be 25. But here, the latest finish will be 45 minus 15 minus 15, 45 minus 15, that's 40 minus 10, that's 30 here. So that's how it works there. And then, oh, we had not calculated the, we can also calculate, yeah, we can also calculate the earliest start there. So, the earliest start here will be 20 plus 30 will give us 50 here. Now, latest finish, we'll take this one, which is 55, and then latest start will be 55 minus 30, which will be 25. And that's how you complete a critical part analysis diagram. Remember, if you need any tutorials, contact Oscar Diura at gmail.com. And also remember to subscribe to the channel so that we can keep on uploading videos. Thank you.